Hi friends, welcome back to MathsGenii, and today we're going to start with questions of Maths Olympiad, and we are bringing you series of chapter-wise questions on it. Why is it important though to give Maths Olympiad in the first place? It challenges the students' analytical thinkings and prepares them for future competitive exams by testing a student's aptitude as well as the basic knowledge of mathematics that will be needed in all the future exams that you would be giving or you would be attempting after the class 10th. We have a lot of more practice questions, mock test to help you score well in your exam. Do check it out on our website. Let's start with past year Olympiad questions on the chapter Real Numbers. Let's first start by understanding the meaning of the word real numbers. So, what are real numbers? Any number that you can point on the number line is called as the real number. Okay, any number, any fraction, any number in root, anything that has a value and you can plot it on the number line is called as the real number. Now real number also has two parts, which is rational number and irrational number. So if I have to give you the example of rational number, all the numbers like 2, 4, 5, 6, 7, 8, 9, all the numbers are rational numbers because they are ending, right? 2 has a end, 3 has a end, 4, 5, all the numbers are rational numbers. But then what do I mean by irrational numbers? You would have studied pi, right? You would have studied pi in your 10th grade. Pi value is 3.141414 and so on. It keeps repeating. It has no end. Hence, it is called as irrational number. Again, irrational number is also, for example, root 2 is also irrational number. What is the value of root 2? 1.414 and so on. Similarly, root 3 is also example of irrational number. So you have to remember these examples. These are frequently asked examples. So because these values have no end, hence it is called as irrational numbers. These values are terminating, finite. It has some end. For example, 8 upon 2. If I cancel this out, 2 ones are 2, Forza. So 4 has end, correct? It's ending. It's not having a repeating structure. Hence, it's called as rational number. Now let's look at some of the questions that has come from this chapter in the past year Olympiad papers. Now let's look at the very first example. So 1 upon root 2 is a dash number. Irrational, rational, whole, none of these. So let me start with whole. Whole numbers are what? The numbers starting from 0, 1, 2, 3, and so on. Rational numbers means those who are having an end, and irrational number. So root 2 was an example of irrational number. So its answer is irrational. So remember, root 2 is an irrational number. Again, here also root 2 is coming. So it's a irrational number. Correct? In seconds, you are able to solve such questions. These are very easy questions. Now let's look at some of the tougher ones. So, two tankers contain 1305 liters and 450 liters of petrol respectively. Find the maximum capacity of container. So this is a big number given in the question, and in the option small number is given. So hence I will find HCF. I'm telling you the difference of HCF and LCM. How to understand in which question you have to find HCF and in which question you have to find LCM. So for HCF, if the given information is bigger and your answer expected is smaller, so you have to find HCF in this case. So let's find HCF. How to find HCF? So first we will factorize both of these numbers. So factorization is very important, students. Factorization is very important. If you are not aware with factorization, you should practice. It's not very difficult. With practice you will get to know the factorization. Okay, so now let's factorize this. Okay, so end you see 5, so I will start with 5. I'll divide this number by 5. 5 2s are 12, 1 remaining, 6 are 1s are. So you can divide like this also. Okay, you can, if you are not able to write directly, you can divide and write 5 2s are 10, 2 remaining. So you can divide and write 6 are 30, 0, 5 comes down, 5 ones are 5. So 261. So you can divide and write. But I am writing directly because I am calculating in my mind. So again, let's see with what number this can be divided. At the end you have 1. So it cannot be divided by 2. Let's check for 3. How do you check for 3? 2 plus 6, 8. 8 plus 1, 9. 9 comes in 3's table. Yes. So it is divisible by 3. 3 8s are 24. 26 minus 24, 2. 21 remaining 87. 87 is also divisible by 3. So 2s are 29. 29 does not come in any table. So I am leaving it till 29. So here is your here are your factors for 1305. Again, end you have 0, so it is divisible by 5. 5 9s are 45, 0 as it is. Again, you can divide it by 5. 5 uh, 5 1s are 5, and 18 you can write it like this. Then 3s are, then 3, where does 18 come? 6 are, 3 6 are 18, right? 3 2, 3 divided by 6 is 2, 2 divided by 2 is 1. So, how do you find HCF? You just consider one time. You consider all these parameters only one time. So, in both, what is common? In both, what is common? 5, 5, one time common. So, I'm writing one time. Then again, what is common? 3 is common. So, I'm writing 3 ones. Again, one more pair of 3 is common. This and this. So, I'm writing 3 again. So 5 threes are 15, 15 threes are 45. So your answer is 45. So for HCF, what do? You find common factor and write them only once. Okay. Now let's move to the next question. In school annual day, again, see, in school annual day, a group of 550 students need to march behind 286 members. So there are 286 students standing and 550 behind them should stand. And the two groups have to march in the same number of columns. So we have to make columns for students to stand in a row. Understood? Again, now how to decide what to find HCF or LCM? I had just explained. Look at the question. Question given number is bigger and options are smaller. So you have to find HCF again. HCF of what students? 550 and 286. So let's find it out quickly. 550, 286. Okay. So 0 at the end. So can I divide it by 5? Yes. 5 ones are 5, 5 ones are 5. 0 as it is. Can I divide it by 5 again? Yes. 5 2s are 10. 1 remaining. 22. 22 can be divided by 2. Ones are ones are. 11 cannot be divided by anything, so 11 as it is. Now, now this can be divided by 2. So 2 ones are, 2 fours are, 2 threes are. This number can be divided by 11. 11 ones are, 11 13s are. So 13 comes in only 13's table. So for HCF, what I had told you, remember, you have to find pair. 5 is there in this, no, rejected. 5 is there in this, rejected. 2 is there in this, yes, accepted. So 2 I'll write once. 11 is there in this, 11 is there in this, so I'm again writing it once. So your answer is 22. So tick mark 22 in the option. Okay, remember, always remember the trick that I just taught you, how to decide LCM or HCF. Again, a little tougher question. Find the largest positive integer that will divide 120, 1245 and 670, 1245 and 670, leaving the remainder. So it is talking about remainder, hence I'm doing minus. For this, the remainder is 13, and for this, the remainder is 10. So 1245 minus 13 is 1232, and 670, and 670 minus 10 is 660. Okay, now I have subtracted. Now I can find. Again, how to decide HCF or LCM? Look at the question. Question has bigger number and options have smaller number. So again, I have to find HCF. So let's find HCF of these two numbers. You can always pause the video, go at your own speed, replay the video and check your own steps. Okay. So end you have 2. So I am starting with 2. 2 6 are 12. 2 ones are 2. Carry 1. 6. Again I am dividing it with 2. 3s are 0. 16. 8s are. Then again I can divide it by 2. 1. 5. 4. Again I can divide by 2. 7s are 14. And 1 carry 7. So this can be divided by 7, correct? So I will have 11. Here I have 11. And then I have 11 divided by 11, 1. Again here, let's start with 2. 2 threes are, 2 threes are 0. Again I'll divide by 2. 2 ones are, 6 are, 5s are. Then end you have 5, so it will be divided by 5. 5 threes are 15, 1 carry 15. Then again I can divide it by, correct? So now again we have to find pairs of common factors. So 2 repeated once, I'm writing it once. Then again I can see, oh, 2 is repeated one more time. So I can write it once. 2 is repeated third time, no. 7 is there in this, no. 11 is there in this, yes. So 2 twos are 4, 4 11s are 44. So your answer to this question is 44. If you want, I'm keeping this question. Okay. Next question. Which of the following is not an irrational number? Very simple, students. Very simple. I taught you in the examples, right? All these prime numbers. I hope you guys know what prime number is. 2, 3, 5, the numbers which do not come in any table. Okay, so I had given you an example of irrational number, if you remember. I'll go to that page. See, I had given you example root 3 is a irrational number. Correct? So all the options with root 3 are irrational, but he is asking me not irrational. So this is irrational. This is irrational. 11 also does not come in any other table other than 11. 11 comes in only 11's table. So this is also irrational. But whereas if you see this 5 plus 6, and what is the value of root 25, students? Square root of 25 is 5. So 5 plus 6 fives are 30, 35. So this is a number. So this is not irrational. All these are irrational, but this is rational. Okay. Not, he asked me not. Correct? The LCM of two numbers is 882 and their product is 6174. Find the HCF. Now students, for this there is a formula. Okay, there is a formula. Remember this formula. What is the formula? HCF into LCM is equal to product of two numbers. So what is given in the question? The LCM is 882. Okay. And their product is 6174. And find HCF. So HCF I don't know. So this is in multiplication. When it goes that side, it will become division. So when you divide this, you get your, so you can divide it as you wish. Okay. So I'll tell you a trick with which I divide. So at the end of this number you see 2, and at the end of this number you see 4. So in 2's table, when does 4 come? 2 2s are 4, or 2 7s are 14. Correct? Only in these two cases 4 comes at the end. So I will try to check. So when I'm dividing, so when I am dividing 882, when I am dividing 882 with 6174, I will check the end digits. So I will try 882 2s are 4, 16, 1764. Is this 1764? No. So rejected. Now let me try 882 sevens are. 7 2s are 14. 1 carry. 7 8s are 56. 56 plus 1 57. 7 8s are 56. 56 plus 5 61. 6174. So 7s are is your answer. So 7 is your answer. What did I do? I applied the formula and then I just divided. So 7 is your answer. Now next. Again an interesting question. How many prime factors in the prime factorization? Okay, so what he wants you to do is factorization. Factorization of this big number. Okay, what is the number? 4002075. Let's factorize this number and check what answer are we getting. This is a big number, so steps will be much more. Okay, at the end you have 5, so I will start the division with 5. So you can divide like this. Okay, if you want you can always go and divide like this. I am not doing it because I have been, I know tables and I can do it orally. So 5 40 8 za. So you can always pause the video and try to divide by yourself. Again 5 is coming at the end, so I'll divide by 5. 1 za, 6 za, 0 za, 0 za, 8 3. Now I can't divide by 5. I'll have to divide by 2. Cannot be divided by 2 because at the end you get 3. Can I divide it by 3? 1 plus 6, 7. 7 plus 8, 15. 15 plus 3, 18. 18. So when you add these numbers, and if the addition comes out to be something that comes in 3 stable, then you can divide it by 3. So addition was coming to be 18, so I can divide it by 3. Okay, so when you divide it by 3, it becomes 5, 3, 3, 6, 1. Again, check for 3's divisibility. 5 plus 3, 8. 8 plus 3, 11. 11 plus 6, 17. 17 plus 1, 18. 18 comes in 3 stable, so I can divide by 3. 1, 7, 7, 8, 7. So can again, let's check for 3. 1 plus 7, 8. 8 plus 7, 15. 15 plus 8, 23. 23 plus 7, 30. So 30 comes in 3 stable. So I can divide it by 3 again. So it comes out to be 5, 9, 2, 9. Again, check for 3. 9 plus 5, 14. 14 plus 2, 16. 16 plus 9, 25. 25 does not come in 3 stable. So I'll have to check for some other number. So let's check for 7. If you try dividing by 7, 8s are 4s are 7. Yes, dividing by 7. Again, let's check for 2. Not possible because 7 is at the end. Let's check for 3. 8 plus 4, 12. 12 plus 7, 19. 19 does not come in 3 stable. So let's look for another number. So I'm taking 7. If I divide this by 7, you get 1 to 1. And everyone knows 1 to 1 is 11 square. So, now we are at the end. And now let's count the factors. What did he ask me in the question? Number of factors. So let's count the number. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is your answer. Now let's look at the next question, which is the number 1.21111111 is an, of course, it is an irrational number because you see it is repeating. The value 211 is repeating 211, 211, 211, and it will keep on repeating. So it's a irrational number. Again, see, now look at this question. Root n is an irrational number if natural number can be anything. 1, 2, 3, 4, 5. Natural numbers could be anything. Prime numbers, will come to prime numbers at the end. Even numbers are what? 2, 4, 6, 8. What are odd numbers? 3, 5. Okay. What are prime numbers? That is my important point here. What are prime numbers? Prime numbers are the numbers which do not come in any table. So 1 is neither prime nor composite. So 1 I don't consider. Prime number starts from 2. 2 comes in any table? No. 3 comes in any table? No. 4 comes in a table? Yes. 5 comes? No. 6 comes? Yes. 7 comes? No. So if you put any prime number in root n, if you put root 2 example, it's a irrational number. If you put the next prime number 3, it's a irrational number. But if you put you can put, if you put 6, 7, so if you put 4, root 4, answer is 2. Is it rational or irrational? It's a rational number. So for this question, if you put a prime number in root, if you put a prime number in root, the answer is always going to come never ending. So its answer is irrational. Now this question. This question involves a formula that you might have studied in standard 8th. Okay, very basic formula. Which formula am I talking about? Do you remember the formula which was a plus b the whole square? What is the formula? A square plus 2ab plus b square. And there was another formula, a minus b. The formula remains the same, only the plus sign here becomes minus sign here. 2ab plus b square. Now in this question, this is a, this is b. So a square plus 2ab plus b square. Again plus sign. For this, this is a, this is b. A minus b the whole square. A square minus 2ab plus b square is the formula. 7 square 49. 2 into 7 14. 14 root 3. This square root and square gets cancelled. So 3 plus 7 square 49 minus 2 into 7 14 root 3 plus this square root and square gets cancelled. So 3 is the remaining part. Now plus 14 root 3 and minus 14 root 3 gets cancelled. Now when you add all this, when you add 49, 3, 49, 3, what do you get? 104. So your answer is 104. So what is the option given? What is it? It's a rational, irrational. What is it? It's an ending number, right? 104 is a ending number. It's not a never ending number. So the answer is it's a rational number. Are you getting your answer as dot 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 dot? No. Hence it's a rational number. Which one of the following rational number have non-terminating representation? What do you mean by non-terminating? Again, if your answer is coming as dot 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 dot, it is called as non-terminating. It's a very simple trick. Pay attention, pay attention. There's a trick. Trick to find non-terminating. Or if you do not remember the word non-terminating, remember it as dot dot dot. So in the denominator, if you have anything in the form of 2 into 2 into or 5 into 5 into or 2 into 5 into, then yes, it does not come in this category. It's terminating. It is terminating. But anything other than this in denominator is non-terminating. You will understand by example. So let's only look at the denominators of every question. Here the denominator is 25. 25 is 5 5s. So it is terminating. Okay. Then let's look at this example. 16. 16 is 8 2s. 16 is 8 2s. Can I write 8 as 4 2s? Can I write 4 as 2 2s 4? So everything is 2 2 2. Okay, this answer is also finite. It is not the dot 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 answer. Now let's look at this. Or before going at this, let's look at this. 45. 45, if you look at, it is 9 5s are 45. 9. See, anything other than 2 or 5 is not accepted. Anything other than 2 or 5 is not accepted. Here you are getting only 5. Here you are getting only 2. But here you are getting, here you don't have 2 or 5. You have some other number only. It's 9. So your answer is this. So the trick is, if in the denominator 2 or 5 comes, only 2 or 5, then the answer is correct. But if there is anything other than 2 or 5, then the answer comes in dot 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 format. Matlab non-terminating. Now let's look at this. There's a trick. There is a trick to this. Pay attention. Again, a trick. Always in multiplication. So here everything is in multiplication, right? What is the remainder? So this is a trick for 10. Remainder trick for 10. What is the remainder trick for 10? Whatever is the last digit. Okay, I'll multiply this. I'll multiply only the last digits, okay? This is last digit is 7, this is 3 and this is 6. I will multiply only this. 7 multiplied by 3 multiplied by 6. Multiply last digits, okay? 7 3s are 21. 21 6s are. If you don't know how to calculate, you can simply 6 1s are 6, 6 2s are 12, 126. So last digit is 126. Last digit multiplication is 126. Now you have to find the remainder if divided by 10. So anytime you have 10, no, whatever is the last digit is your remainder. Last digit is what? 6. Your answer is 6. As simple as that. It's a trick. It's a trick. Okay. Now, this is a very good question. The product of three consecutive natural numbers is always divisible by. Firstly, you should understand the meaning of consecutive. Consecutive is one after the other. And natural number. Natural number starts from 1. So 1, 2, 3 consecutive, 2, 3, 4, one after the other. So 1, 2, 3. It says the product of three consecutive numbers. So 1, 2s are 2, 2, 2, 3s are 6. So 6 is divisible by what? 6 is divisible by 6 only. Let's look at some other example. No, let's look at 4, 5, 6. 4, 5, 6. What is he saying? The product of three consecutive. So this is three consecutive, product of that. So 4 5s are 20. 20 into 6, 120. 120 comes in 6 table, of course. So any number you take like this, any number, if you take 11, 12, 13 also, or if you take 13, 14, 15 also and multiply them, every digit, every consecutive, one after the other, consecutive means one after the other, every consecutive natural number will always be divisible by 6. We just saw the example. I hope you liked this video. Stay tuned for the future videos. See you soon. Bye bye.